I'm Avidit Acharya, and I'll be introducing the presenter and moderator for today's talk. Today's speaker is Dr. Jayash Paudel. Dr. Paudel is an assistant professor of economics at Boise State University. His research lies in the fields of environmental economics, natural disaster economics, climate adaptation, land and agricultural economics, food security, and development economics broadly. His research has appeared in journals such as the Journal of Comparative Economics, Land Economics, and World Development, among others. He is also affiliated with the Berkeley Initiative on Transparency in Social Science and the Hazard and Climate Resilience Institute. He previously worked for the Poverty Action Lab at MIT and for the World Bank, and he earned his PhD in Environmental and Resource Economics from the University of Massachusetts at Amherst in 2019. Now, the moderator for today's talk will be Dr. Sanjaya Acharya. Dr. Acharya is a research director at Saraswati Multiple Campus, Trivandrum University. He was previously a full professor of economics at Ritsumeikan University in Japan and an associate professor of economics at Trivandrum University. His research is broadly in the areas of development economics as well, and he has published more than 24 peer-reviewed articles in international journals on a variety of topics that include the effects of trade liberalization on the Nepali economy and society, remittances, gender and community development, economic growth, and poverty alleviation. He is the author of a book titled Pro-Poor Growth and Liberalization in Developing Economies, published by Routledge Press in 2012. Between 1995 and 2011, he led a series of research projects at New Era Kathmandu, and he holds 2 PhDs in economics, one from Erasmus University in the Netherlands and another from Hokkaido University in Japan. So now, before Jayash starts, let me remind our participants of the ground rules. Please remember to keep your mics muted unless you are invited to speak. Dr. Pordell will speak for about 40 minutes. Then we will have a half-hour Q&A session moderated by Dr. Acharya. You may send in your questions via chat or use the raise hand feature on Zoom. As always, we thank the IIDS staff, particularly Ms. Vinisha Nepal, for supporting this series. All right, Jayash, go for it.
Thank you, Dr. Acharya, for the nice introduction. I would like to start my talk mentioning that we've been experiencing this tragic pandemic over the last 15 months, and I know that the situation is much worse in India and in Nepal right now. So I really hope this finds your friends and families and friends of families really safe right now. With that note, I would also like to mention that IIDS has done a fantastic job of inviting great colleagues over the last few months, and I'm really happy to be here talking a little bit about my ongoing research. So I am a trained environmental economist, as was mentioned at the beginning. I do some work looking into how economic agents adapt to natural disasters in different capacities. And today what I'll be presenting is a part of my ongoing work looking into one specific study, exploring the linkage between forest fires and property values. So the current manuscript that I'm presenting is titled Environmental Disasters and Property Values, Evidence from Nepal's Forest Fires. I don't think I need to work too hard to motivate the significance of this topic, given this audience that we have this evening, but I will go ahead and present some statistics that will sort of strengthen the reason why we should be doing more research in this arena. This estimates from Food and Agricultural Organization indicate that globally, forest fires affect almost 20 million hectares of forest every year. The situation is much severe in the context of the developing world. For instance, Nepal faces a recurring threat of forest fires every year, losing almost 200 hectares of land annually. If you look into the satellite MODIS data over the last 19-20 years, you'll find that there were roughly 47,000 unique fire incidents that were reported in Nepal alone. And just to give you an example on the severity of this problem, back in 2016, over 1,200,000 community managed forests were affected, right? That covered 1.3 million hectares of land and almost 15 people were killed back in 2016. Now, this is important because forests comprise almost 40% of Nepal's total land, and clearly forests have an important role in protecting water shades, conserving soil, and maintaining biodiversity. Although evaluating the economic cost of forest fires is a public policy issue, it is not clear whether households in the developing world respond to risk of environmental disasters such as wildfires, and whether they take any risk mitigating measure to deal with such environmental shocks. Okay, and that's where this paper I'm presenting today comes in, where the primary objective is to evaluate the short-term economic impact of forest fires on residential property values across districts of Nepal. To explore how households adapt to these environmental shocks such as forest fires, what I do is I exploit plausibly exogenous distribution of past forest incidents across space and time. Essentially, I'm looking into sort of variation in different indicators of lagged forest fires across districts and different months of a given year. To explicitly look into how households respond to forest fires, my empirical specification is going to benefit from a combination of detailed nationwide household surveys done by Central Bureau of Statistics in 2014 and 2015 with the satellite data on active fire locations, which I'll talk about in more detail in a few minutes. Essentially, my empirical specification takes advantage of modeling current property values as a function of monthly lagged fire-related indicators. And there are two indicators I use in this study, one being whether households experience forest fire in the previous month in the same district where household is located, and monthly lagged fire-related power, which I will explain in a few minutes as well, associated with forest fires in the same district. And clearly, I also account for annual incidents of forest fires, different district unobservable heterogeneities associated with determinants of property prices or property values, and month by year fixed effects, which will indirectly capture month by year varying shocks, such as macroeconomic conditions, earthquakes, and other policies that may have affected all districts in the sample, and different other characteristics such as demographics and other household controls. So that's kind of the overall sort of essence of the model, and I'll talk about that in detail in a few minutes. Before I dive into the empirical strategy and economic and policy implications of this study, I would like to quickly sort of summarize the main findings in case if some of you may have to leave a little bit earlier. There are three set of main findings associated with the study. First and foremost, I find that forest fires have a strong negative short-term economic impact on residential property values. Specifically, I report that for every unit additional increase in fire-related power from forest fires reported in the last month, a household's current residential property value declines by 0.61%. And I'll talk about what this 0.61% really means in terms of economic significance at the end as well. Across different sets of empirical specifications, I find that this marginal effect associated with lagged values of forest fires range between roughly 0.56% and 1.18%. Now, what I do here in the paper is I am also able to look into sort of a little bit of a medium-term impact of forest fires on residential property values. And in fact, to explore the cumulative effect of forest fires, I also look into sort of the aggregated measure of forest fires over the last 12 months. And I find that for every unit additional increase in total number of fires reported over the last 12 months, property values of households declined by 4.25%, suggesting that the medium-term impact is much larger in magnitude than the immediate shock that we see over a time period of a month. Third, and more importantly, one of the key messages of this study is that, sure, these environmental disasters have a negative effect on property values, but what about heterogeneity across different provinces and different socioeconomic groups? And in fact, I document that these estimates are more pronounced in Karnali and far western provinces. And I'm not really able to causally tease out what that mechanism could be, but I do find, given the data that I have, that in the empirical sample that I'm looking into over the time of period in the study, the number of forest fire incidents is much more higher in these provinces compared to others. And I'll present that in a few minutes as well, as far as the map is concerned. So with these three key findings in your mind, I would like you to kind of sort of look for the empirical strategy, which I'll mention in a few minutes, and hopefully the key policy implications of these findings will be of interest to you in a few minutes. And before I dive into data, how do I do the merging? How do I take care of the identification strategy? I just want to highlight three key contributions that I argue this paper makes, given the literature. First and foremost, there's large ongoing literature looking into how economic agents capitalize perception of risk into housing prices. And in particular, I'm looking into this channel in the context of forest fires. Now, prior literature has kind of looked into these things over a longer period of time, but they are mostly focused in the Western United States, as I will talk about comparison of my estimates with prior literature as well at the end. But there's not much as far as the developing world is concerned. In fact, to the best of my knowledge, this is the first study in the context of developing country setting where I'm sort of trying to quantify the external cost of forest fires using the data that I will be presenting shortly. Second, as I mentioned, the key contribution that I argue here is that there's a lot of spatial heterogeneity across provinces and to some extent across socioeconomic groups as well. What this really indicates is that as policymakers are thinking about allocating a limited amount of budget towards management of fire across different areas, right? Maybe there are some provinces that are ranked much higher in terms of the help that they need. And so it will hopefully contribute to kind of optimal allocation of funding as far as mitigating forest fire is concerned. And I'll talk about that in a few minutes as well. And so the third contribution I want to highlight here is, what about economic and policy implications, right? And I know this audience cares a lot about these things, given my experience attending prior webinars here. And so I will sort of come up with a few back of the envelope calculations to kind of make us think through why this issue is much more important than it may seem. All right, so that's kind of the overall structure of the manuscript I'm presenting. Next, I would like to kind of delve into data directly, and then I'll spend some time talking about the empirical strategy and some limitations associated with it. And then I'll sort of quickly present the main findings, and we'll spend some time thinking about what can we learn from these findings, what are the key policy implications, and then I'll be happy to answer other questions you may have as I present the rest of the slides. All right, so data, I want to specify that two sources of key data that I'm exploiting in this study. The first is a nationally representative sample of households done through annual household survey conducted by the Central Bureau of Statistics in 2014 and 2015. And I will present to you in a minute how the overall empirical sample looks like. Essentially, overall, approximately 30,000 households were interviewed, different months in 2014 and 2015. And we'll see that in a few minutes. And what I do is I collapse this, I essentially merge this household level data with satellite data on active fire locations. Now, I should mention that unfortunately, this AHS data does not include geographical coordinates of where households are located, right? So I'm not really able to kind of compute the distance between where a household lives versus where the site of fire happened. So what I have to do in this case is I collapse my satellite data on active fire locations at the year, month, district level, and then I merge that with the household survey to essentially look into the linkage between forest fires and property values. And there are some limitations associated with FROM's data as well, which I'll mention in a few minutes, but that's sort of the overall data management process as far as the study is concerned. All right, so here I have a map of Nepal for you. This is essentially based on my empirical sample of fires reported in 2014 and 2015. You can see the district names, and each of those red dots essentially gives us where forest fires were reported within that time period. And what this paper is essentially suggesting is that at least the incidence of fires in terms of the count, right, that seems to be much more pronounced in the hills and in the southernmost part of the country, right? And it's interesting when we think about quantifying forest fires, right? There are different indicators out there that's available. And I'll talk about, why or what indicator we should be using in thinking about the severity or the incidence of forest fires. And so here I'm presenting to you the count of average forest fire incidents at the district level, right? Just to kind of give you a sense of geographical heterogeneity. So that's one indicator if you will think about quantifying forest fires. The other indicator that's pretty common in literature is called the fire radiative power. And before I sort of talk about that, let me quickly sort of show you what this map on average count is essentially indicating, right? So as I mentioned in the previous figure, right, it should not really surprise us, this this region of the country kind of shaded in dark blue is essentially telling us that the number of fire incidents is much more pronounced in the southernmost part of the country. But this pattern is not quite the same when we think about intensity of forest fires, right? So this average count is telling us about the incidence of forest fires, but what about the severity? What about the intensity, right? And to quantify intensity, what remote census experts have come up with recommending is to use a fire radiative power instead, right? So fire radiative power is the average radiant heat associated with forest fires, right? So in some sense, it's not really telling us about the count, it's telling us about how intense the fire is, right? And so what this map is essentially plotting is the average fire radiative power at the district level, and you can see that the intensity seems to be much more larger in magnitude in the upper belt of the country, right? So the areas shaded in dark blue range between 19 megawatts and 51 megawatts, which are much more larger in magnitude compared to what we see in the lower belt of the country. And this is important in this study because when we think about capitalizing on risk perception in response to these shocks, right? Should we be thinking about counts of fires? Should we be thinking about intensities? And so we'll see that depending on what indicator we're kind of exploiting to quantify the effect of forest fires, the findings may be a little bit different. And that's what we'll see in a few minutes. But I just wanted to kind of give you a sense of how geographical heterogeneity in fires look like, given the sample that I have here. And finally, before I present to you the details behind the empirical strategy, I just kind of want to present to you a figure that kind of motivated me to even dive into this project to begin with. So what you see here in this figure is on the y-axis, you have the current property values in rupees based on the sample of data that I have. And on the x-axis, you have last month's fire radiative power associated with forest fire events in the same district where households are located. And to generate this figure, what I do is I collapse my property values data at the year, month, and district level I use those collapse values to generate the average and the standard deviation, which essentially gives me the upper and the lower bounds. And I'm essentially just trying to look into the correlation between those collapsed property values and last month's fire radiative power, right? And so what this figure is essentially suggesting is there's an inverse relationship between these two variables, right? As last month's fire radiative power increases in magnitude, seems like property values seem to decline, right? And so that was kind of the key sort of graphical illustration that motivated me to dive into this project a little bit deeper, which I will talk about next, in fact. So I know this audience cares a lot about selection bias, heterogeneity, and different issues associated with econometrics. So I'll do my best to be as transparent as I can. And if you have suggestions, if you have other issues that I should be mindful of, I'll be happy to talk about them or respond to them in whatever way I can. So the only equation that I'm presenting to you is right in front of you here, equation 1. Essentially, I'm modeling my y variable as a function of lagged fire-related indicators, right? So on the left-hand side, you can see letter y corresponds to self-assessed residential property value in logs for an individual I located in district D in the current month M of a given year, okay? And on the right-hand side, right, what I'm really interested in is beta 1 and beta 2. Those are parameters of my interest. Fire is essentially an indicator that tells me whether a forest fire incidence occurred in the same district in the previous month or not. So that's a binary indicator. And then the variable of interest is in fact fire radiative power that I will talk about in a few minutes. Fire radiative power, again, is the measure of intensity of fire associated with events reported in the same district in the last month, right? So when I'll be presenting to you the regression findings, I'll be looking for beta 2 and beta 1 to see what we learn from those. On top of these two indicators, I'm also exploiting the average fire radiative power over the last 12 months, as well as the average count of fires over the last 12 months, just to look into whether the cumulative impact of fires might be different on current property prices. And that's what vector F bar essentially gives us. So in addition to these 4 different fire related indicators, vector X is pretty standard, presenting to you a vector of household controls, demographics such as household size, right, type of the property, and then caste status, gender, and so forth. In addition, I also have district level fixed effects to account for district level unobservable heterogeneity, such as political instability and institutional strength, right? That's given by this letter eta here. And then delta is essentially the month by year fixed effects that will indirectly control for month by year varying unobservable determinants of current residential property values. And finally, I also include quadratic monthly district level time trends, right? That will account for unobservable trending variables that might be predicting current assessed residential property values, right? And I do control, I do cluster the standard errors at the district level because that's the level at which the treatment is essentially kind of being presented here, okay? So I know this is the equation right here that you can see, but there are 4 different key methodological issues that I should be transparent about, right? And so let me kind of present to you those 4 key limitations before I talk about the key results. All right, so the first issue with the approach I undertake here is that I have access to self-assessed value of a residential property based on the annual household survey data, right? How does this variable, how is this variable constructed, right? And so the survey essentially asks each respondent, if you'd like to buy a dwelling just like the one you own today, how much money would you have to pay? Okay, and that answer to that question is essentially the self-assessed value of residential property that I'm kind of using here. Now, the problem is if you look into hedonic valuation, hedonic models that you see a lot in the literature, right? It's a complex topic in that usually, right, an ideal setting for a hedonic model relies on price, transactions from the competitive market, right? That's certainly not the case in the Nepalese setting where our housing market tends to be much thinner, right? And so if you go back to classic Rosen paper from 1974, right, hedonic model would kind of want to have sort of the transaction from the competitive market, demand price being equal to offer price at equilibrium. Clearly, that's not the case here, right? And so what that really means is there's potential bias associated with this approach that I'm taking. The good news, though, is this is pretty common in literature as far as the developing world is concerned. In fact, there are a couple of two papers by Dr. Mani Nepal. I don't know if he's here, but he's been here in the previous IIDS webinars. And so, he and his collaborators have done some great work kind of trying to come up with sort of the limitations with this approach. And so I'm kind of piggybacking on some of the prior work that has been done in the context of Nepal. The good news here is that although there's potential bias associated with this approach, the magnitude of estimated bias is in fact much smaller, right? It's average between 3 and 8%. And so I'm kind of taking advantage of prior literature to sort of support the idea that maybe the bias associated with self-assessed value is not as severe, as prominent as one would expect. But keep in mind that it's not feasible to collect property price transactions in the Nepalese setting, right? Both buyers and sellers might have an incentive to understate the prices to avoid stamp duty, right? And so because there's this potential underreporting of sales price that might happen, right? It's a little bit beyond the scope of the study to kind of benefit from those. And to the best of my knowledge, I haven't come across a database of sort of those property price transactions as well, which is why I end up taking advantage of self-assessed values of residential properties from the AHS database. The second issue I want to be open about here is I'm using fire radiative power as a proxy for fire intensity. And you might be wondering, why am I doing it, right? So Baumann et al. 2017 is this new kind of upcoming, got published recently that sort of uses daily clusters of fire radiative power across the globe from 2002 to 2017 to quantify the sort of the magnitude and the scope of forest fires across the entire globe, right? And so I'm kind of using remote sensing literature to kind of sort of use fire radiative power as a proxy for fire intensity. The good news about this indicator is that it's strongly correlated with fire behavior characteristics, right? Such as total amount of biomass burned, total intensity associated with the fire events. Some economists like to claim that fire size might be a better proxy. I argue that based on literature, right, fire size is actually contingent on landscape characteristics, and it tends to be dependent on the nature of place we're looking into. So the actual value of economic loss, in fact, is contingent on fire magnitude as opposed to fire size. And so that's the reason I'm not using fire size. Well, I also do not have data on it, but literature has kind of argued that fire radiative power is a better proxy to sort of quantify economic losses, and that's why I'm sort of using it here. And finally, right, estimating burned area per fire pixel, it's also going to cause a lot of substantial spatial temporal sampling issues documented in the remote sensing literature, which I'm not really sort of using it here, but that's something we might want to be mindful of as we think about why we're using fire radiative power in this context. Third, and a more important issue as far as economists are concerned, is unfortunately we do not have geographical coordinates of residential properties, right? Unfortunately, what that really means is I'm not really able to detect which households are in close proximity to the site and which are much further away, right? And what that really means as far as interpretation of my parameters or findings in the study is that how do I interpret these estimates that I'll be presenting, right? So there are different mechanisms through which fires may influence property prices, right? I can sort of have some indirect evidence that majority of houses in this empirical sample are likely free of actual fire-related damages. That's coming from sort of different housing characteristic questions that the survey asked. And I'm kind of interpreting the fact that their housing characteristic looks a little bit more stable. That can be kind of interpreted as that maybe it was not directly damaged by the fire. So what that really means here is I'm interpreting my parameter of interest more in terms of risk perception as opposed to actual fire damage, right? So there are different mechanisms through which fires may in fact play a role here, right? Some of these channels include damage of fire, visual disamenities, right? And also high perception of risk. And I argue here that the interpretation of the parameter that I'll be presenting to you should be thought about in terms of perception of risk as opposed to actual fire damage. So what that also means is the estimated parameter in some sense, are kind of not as large in magnitude, right? So they're kind of underestimated. So the actual impact of forest fire might be much larger in magnitude, right? Given this sort of limitation of data that I have here. And finally, right, satellite data also comprises of different limitations, and that's been documented in some of my prior work as well as remote sensing literature, right? Because satellites detect active fire locations by calculating thermal anomalies within pixels 1 by 1 kilometer in size, right? Multiple, and then the center of fire pixel is essentially identified as where fire happened, right? Multiple fire incidences within 1 pixel area may be reported as a single incidence, right? And so also it is likely that fires may have started and ended between when the satellite observed the event, kind of sort of raising the concern that the quality of pixels might be sort of compromised to some extent, right? But this limitation of satellite data is not only associated with this specific study. Any study that exploits satellite data is going to have to be mindful of these limitations. But I just kind of wanted the audience to sort of think about these key methodological concerns as we think about interpreting the results that I will present shortly here. All right, so let me dive into results right now. Before I present to you the regression findings, I have a table of empirical sample here. So let me quickly summarize what this table is really suggesting us, right? So if you look into a row, if you look into the top row here, right, this is essentially suggesting that in January of 2014, we have a sample of 2,033 individuals from 7 provinces located in 27 districts, where, right, only 2 districts had forest fires and 25 districts did not. And then column 8 and column 9 is giving the average count of forest fires and the average fire related power associated with those fires, right? So when you look into this table, you can clearly see that the number of fire events is much more pronounced during the months of March, April, and May, right? Which is consistent with literature, given how forest fires tend to kind of happen around starting from the dry season, right, from November and kind of last until May of a given year, right? And so you can see that I have broken down the total observations across each month of a given year. So the sample essentially runs from 2014 January to 2015 July, right? And I should also point out that this is not a panel data, right? This is repeated cross-section, right? So we do not have information on the same household more than one time period, right? So this is how the actual data looks like. So if you were to sum all these unique individuals, that would roughly come around 30,800 individuals, or approximately 30,000 observations. And you can see that there's some variation over sort of when and where fires happen. All right, so I have roughly 5 minutes or so left, but maybe I'll try to finish this in the next 10 minutes here. Let me spend some time with the main results. What you can see in the table here is I have 4 different indicators of fires, right? So the first one is whether forest fire is detected in the last month, forest fire radiative power in the last month, right? So that's the proxy for intensity of fire events, which is the parameter of my interest here. And then 2 other variables capturing the cumulative effect of fires, which happen to be number of fires reported in the last 12 months and fire radiative power reported in the last 12 months from these fire events. And moving from left to right, I sort of start including, district fixed effects, month by year fixed effects. And so my preferred specification in column 4 includes all these fixed effects as well as household controls. So there are a few things that I want to highlight here. Obviously, I would like you to look into estimates that are colored in blue, but let me start with the first row here. So I do find that after a forest fire is detected in the last month, there is a negative sort of effect on log property values, but it's not significant, right? So I'm not spending too much time talking about that here. But as far as the intensity of fire is concerned, I do find that that seems to be a key channel here, because you can see that household prices decline by roughly between 0.56% and 1.18% across multiple specifications, right? And so my preferred specification in column 4, as I pointed out, shows that property values declined by 0.61% for every unit additional increase in monthly lagged fire-related power from fire events reported in the last month. The interesting thing here is I also include the cumulative effect of fires, right? So you can see that when I have fire-related power over the last 12 months, I do not see any significant effect as far as sort of the cumulative effect is concerned. However, right, when I look into count of forest fires over the last 12 months, it does seem to have a significant negative effect, right? So you can see that current residential property values declined by roughly 4.48% for every unit additional increase in the number of fires reported in the last 12 months. All right, and so next what I do is I break down these main results across different provinces, right? This is important because as we're thinking about sort of the distributional impact of policies aimed at suppressing wildfires, right? We might want to know which province or the provinces are different or similar in terms of how the effect looks like, right? And you can see that, well, province 1, province 2, and Bagmati province, none of those estimates are statistically significant, although they are negative in sign, right? But the severe effect seems to be kind of centered around Karnali provinces and far western provinces, right? Well, I'm not able to tease out the channel through which this negative effect can be explained. What I can do with the data that I have is I kind of look into sort of the magnitude of fire events between these provinces versus their counterparts. And I do find that in the empirical sample that I have, the total amount of fire incidents, both in terms of magnitude of intensity as well as the count, is much larger in magnitude compared to other provinces where we do not see significant effects. And so that's the explanation I have right now. And that's how I'm sort of interpreting why these provinces have a much larger sort of effect on property prices, right? So this is roughly around 16% in Karnali province, and in far western province, this is roughly around 6%. And so there have also been previous studies that look into how natural disasters tend to exacerbate existing disparities in among different socioeconomic groups. And based on prior literature, I kind of break down the sample into urban households, rural households, and those that are dependent on firewood for fuel versus those who are not. And I do find that although the difference is not statistically significant, households not relying on firewood for fuel tend to have the largest sort of negative effect in response to fire events, as far as the current residential values are concerned. In the past iterations of my paper, I've done tons of robustness checks. I'm just including 3 because they will be included to the main version of the manuscript. And so some of your questions that you might have later on, I'll be happy to answer them as far as how do I address them to kind of explore how the validity of estimates may look like. But here, what I do is I kind of drop the outliers and I find that the estimates are still robust, right? And I also look into different measures of fire intensity, and nothing really sort of changes the magnitude of the effect that I presented to you earlier. And finally, right, placebo test is very important here. What I do is I conduct 500 sets of different placebo regressions in areas where sort of fires did not really take place, right? And I randomly allocate sort of randomly assign values to my key variables of interest, and I kind of plot a kernel density plot of these placebo estimates and compare where the kernel density plot of the placebo parameters are located compared to the main estimate I presented to you earlier, right? And you can see that the main estimate in table 2 that I presented is much outside of the placebo kernel density plot, kind of suggesting that gives me a little bit more confidence on the validity of the regression strategy that I pointed out earlier. Okay, so what do these findings really mean, right? What can we learn from these, right? And so very briefly, I want to compare how my estimates in Nepal look like as far as a bunch of other studies in the US have been done, right? So McCoy and Walsh, this is the most recent paper that came out in JIM, essentially looking into how housing values decline quickly in response to a temporary shock of forest fires. And in this paper, they benefit from high-risk fire map zone information, which we do not have in the context of Nepal. You can see that majority of US studies are focused on the Western United States, from states ranging from Colorado to Arizona to California and Montana. And you will see that the magnitude that these studies find is much more larger than what I have reported in the context of Nepal, right? But then we should also be mindful of the fact that comparing estimates in Nepal may not be to US, may not be an apple-to-apple comparison, right? There are a lot of underlying differences, and I would like to kind of highlight 3 or 4 of them here, right? First and foremost, households in Nepal do not have adequate access to risk mitigating mechanisms, such as the provision of house insurance, right? In fact, policy-wise, concrete policy level nudges in Nepal are pretty recent, right? I think the forest fire management policy strategy was first developed in 2010, and the sort of the early warning systems of forest fire came into existence only in 2016, right? So it's a completely different kind of a market that we're talking about. The implication of these differences is that I'm not really able to consider the impact of fire through a spatial dimension, things like how far the household is located from a fire, as well as a visual, right? Does having a view of a burned scar right in front of my house, is that going to play a role here, right? So those are the channels I'm not really able to sort of tease out given the limitation of the data. And the time horizon dimension is pretty key. The US setting tends to have much richer data over a longer period of time. On the other hand, with Nepal, it's a little bit difficult not having detailed household level data for a longer period of time every year, right? And so that kind of brings in some complexities as well. So in terms of the economic significance, right, what can I really learn from these parameters, right? What can we learn from it? If I were to kind of plug in the average property valuation documented from the empirical data using the estimate that I presented to you earlier, the results are suggesting that households exposed to fires report an economic loss of roughly 12,537 rupees per capita annually. Okay, and so I'm just kind of throwing out a number here, right? What does this number really mean? If 7 million people, and it doesn't have to be 7 million, I just kind of came up with a random number here. This is roughly 25% of the total population of our country, Nepal. So if 7 million people were to be affected, right, by fires, that essentially kind of, we're talking about economic loss of $725 million, which is almost equal to 2.37% of Nepal's 2019 GDP, right? So, and we can come up with different numbers depending on how many people are affected by fires, right? But this is just to give you the scope, the magnitude of the back of the envelope calculation that comes from these estimates. So then the question becomes, are government investments to prevent fires adequate? Okay, so you might be wondering, how much amount of money does the government allocate every year to prevent forest fires? You may know this already, right? But it's only $1 million US dollars in 2017, right? So compared to $725 million that I'm kind of hypothetically throwing out here, assuming that 7 million people would be affected, right? This $1 million US dollars seems to be much smaller in magnitude given the scope of the problem. And prior literature, right, by Bendorf and Gondamer actually argues that funding is a key mechanism through which fire prevention efforts could be much more strengthened. All right, so then There are a few policy implications that I want us to kind of think through as we think about, what do these estimates really mean, right? So from a policy perspective, right, we're always interested in sort of quantifying economic benefits associated with reduction in risk of forest fires, right? So what's nice about the Western US, at least in Colorado, is that they do publicize the forest fire risk map, right, to respective households, so they can actually make decisions in terms of mitigating the fire events, which is not possible in the context of Nepal, right? The good news is in 2016, there has been an implementation or at least an introduction of satellite-based early response systems with text message alerts, even in countries like Nepal, Bhutan, and India, right? And so in fact, I'm collaborating with a couple of remote sensing folks here at Boise State. We're trying to look into what's the efficacy of that mechanism in terms of the reduction of forest fires, right? What's nice about a study like this is we can actually predict under a business as usual scenario, right? What does that reduction in fire in response to satellite-based early response system really means, right? We can in fact plug in sort of the slope parameter from studies like these and look into sort of, quantifying the economic valuation of such fire monitoring systems, which I hope will benefit sort of policymakers in the near future. And finally, and more importantly, there have been sort of new studies coming out looking into short-term environmental effects of forest fires. In fact, last year, right, I worked on a study looking into how, when lockdowns were much more stricter, the incidence of human-led fires reduced in magnitude, right? And so there might be some unintended economic short-term benefits associated with sort of reduction of forest fire events that might have to be plugged in when we're thinking about generating the overall comprehensive economic cost of the pandemic, right? So these are a few things we might want to think about in terms of how we can use findings as far as policy is concerned. So with that, I see a bunch of chat messages here. I haven't had a chance to look into them, but I'll be happy to answer questions or concerns you may have. Thank you.
Okay, thank you, Dr. Pordell. I'm going to now invite Dr. Acharya to moderate the Q&A session.
Thank you, Dr. Acharya and Dr. Jayash, for the opportunity provided me to coordinate the discussion sessions. I would like to invite everyone for the next half an hour that we'll continue our discussion on his paper. Dr. Jayash, I would like to thank you very much for this very interesting paper. The topic, the forest fire and its impact on private property value, is quite pioneer in our context, although it might have lots of studies across the globe. Using a hedonic function that you are to demonstrate that in our Nepalese context, the last month's forest fire do have immediate impact to the next month in terms of the decline in property value by 0.61%. And the whole last year's impact of the forest fire, this overall economic impact is about approximately 9.5% in GDP. Then you have also made this result compared across region and over time. That is also very interesting, and you have made some robustness checks, and the results you have concluded that looks quite robust in terms of the robustness check you conducted. And at the end of the paper, you are able to draw some policy implications that could be supportive in our context. I have two small queries in your presentations that you made measurement of the immediate impact of the forest fire in terms of the decline in the property value. But looking from the other side, in the immediate neighborhood, it might have the decline in the property value, but from the demand management perspective, a bit farther from this forest fire locations, there might have similar impact to the rise in the property value, right? So what might be the resultant impact of the decline and rise of the property value? You might have done some sort of counterfactual simulations and measured the resultant effect, right? That would have definitely aided the value of the paper. If that could be possible, that I would like to suggest you in terms of the measurement of the overall impact, please consider both sides, the loss and gain, right? And the similar way, you made this study, the comparative study, in terms of this impact in different locations and over time. The immediate impact compared to the immediate impact, the impact of the past 12 months look higher, maybe 2.5% or something like that, compared to 0.61% of the immediate past month. But even if you take the whole 12 months, your explanation might be that you have captured different different number of this forest fire and overall impact to the property value decline. But even if you take the whole 1 year, this forest fire is a seasonal event that might have last year in one season and this year in one season. So there might be not more than two different events. Why the impact is so high if you take the last year's case to this decline in property value compared to the immediate past, right? You might need further explanations. Likewise, across the region, that the frequency of the forest fire is more in the southern belt of Nepal, that the map you showed, but the impact looks on the north, right? In the Karnali region, far west region, especially in the north, in the hilly region. So why the impact is less in the areas where the frequency is high, right? It may require further explanation. And the household who do not rely on fuel wood and forest resources do have less impact of this forest fire event compared to those households who more rely on the forest resources. How can we understand this? Because the impact of the forest fire might be irrespective to whether the household receive forest resources or not. Why the impacts are different among different households, right? So maybe you may revisit your hedonic functions, that is this the contribution of different constituents to the overall demand, right? So if there we can make some adjustment of the variables that might develop some sort of a little bit more explanatory power in the regression model you have used. Or you can just give the new perspective that you have considered all the perspectives of this forest fire events. So I would like to ask you these a couple of questions. If you have any immediate response on them, please.
Absolutely. Thank you, Dr. Acharya. Those are some great set of questions. And very quickly, let me address them one by one. Your first point on looking into neighboring effect of fires is super interesting. And I'll admit that that's something I would like to do, but that's not a part of this paper. What I'm really thinking about is, do neighboring, does having a fire in a neighboring district, in fact, have a role to play in terms of estimating prices in the neighboring district, right? So I'm kind of not looking at the direct effect of fire on property prices, but indirect effect. And I think in some sense that will address your concern, but clearly that's something that's missing right now. And I'd love to address that in the next iteration of revision if I can, right? And then the second point on why the effect is much more larger in magnitude when we think about 1 year time horizon versus sort of a monthly lagged or 1 month time period, right? Well, one thing that has been pointed out in the literature is that it gives enough amount of time for households to respond, right? So 1 month may not really be enough. And so the other missing mechanism is I'm not really able to look into how households are responding, right? So in the context of the US, at least, when a natural disaster strikes, you can think of households kind of migrating out. And so, migration could be one channel that could happen in response to natural disasters. So channels like those, right? I'm not really able to sort of explain, or I'm not really able to investigate in more detail. So I think there's, as I mentioned, that's a great question, right? Why 1 year effect is so much larger in magnitude compared to 1 month? I think that I agree with you that it deserves more attention. But given the information, given the lack of available data on potential economic channels, I'm not really able to tease that out with the framework that I have. And your third point on why there are underlying differences in Karnali/Far Western provinces compared to other provinces, given that we see there's a high amount of fire incidents in the southernmost part of the country. It's an important one. In the earlier version of the paper, in fact, what I have done is I have kind of decomposed the overall sample by ecological zones as well. So looking into Tarai, mountains and hills. And I do find that the effect is negative and significant in Tarai and the hill region. It's just not a part of the current version of the manuscript because the reviewers didn't really want that to be a part of it. But I think in some sense that also addresses your concern. And I pointed out that one of the underlying mechanisms could be that, at least within the empirical sample that I focus on, the frequency of events is much more higher in those provinces. And so that's the explanation I'm going with as far as my results are concerned at this point of time. But I agree with you that there could be something, hidden mechanism that I should be thinking about. And it's not possible given the data that I have. But I really appreciate you kind of asking these 3 questions because they're very important and I would love to address them. And if you have other specific suggestions on how I can further tease those out, I'll be happy to talk with you in person as well. Thank you, Dr. Acharya.
Okay, thank you, Dr. Jayash. Now, let me ask you to visit this chat box. There are several questions. If you could address them one by one, if that is possible.
Sure.
Starting from Professor Alok Bohra.
Sure. Yeah, so Dr. Bohra is asking me to drop binary fire indicator and looking at the intensity effect and the count. It's interesting, Dr. Bohra. So when I started the manuscript, I had these incidents, these proxies, they were not a part of a single equation, but then the referee asked me to kind of, include all of them in one equation. So that's the change, but I do agree with your concern here that, there could be potential correlation happening. But the good news is, even when I sort of, follow your sort of suggestion of not including the indicator, the estimates are actually of the same magnitude and statistically significant. So I think, I'm not too worried about the bias that you're referring to, but that's certainly, an important point. And it was actually a part of the earlier version of the manuscript as well. The next question is
from Ram Acharya regarding control of district.
Yeah, so I think Dr. Ram Acharya is referring to the fact that housing prices differ so much where the house is within a district. Does this create a potential downward bias in your coefficient? So I will admit that I'm not presenting my results as if they are perfectly causal, right? Given, I'm not really exploiting, the research design is not super clean. And so in the paper, I do talk about potential sources of omitted variable bias and how the bias may be downward. And so, it's something I'm mindful of. And so I just want to sort of offer the caveat that I'm not presenting these findings as if they are perfectly causal. What I'll say is, given the limitation of data we have, given the framework, this is a first step towards kind of identifying the causal effect. And I'm hoping that, further research can sort of tease that out in more detail. So that's, potential bias of the estimates could be happening, and I do not deny that.
Yeah, thank you, Dr. Jayash. Next question is from Kedar Neupane regarding the relationship between forest fire and ownership of real property and others.
So Kedarji's first question on the linkage between forest fires and ownership of real property. Okay, so I think, so you're essentially interested in what percentage of households own the house as opposed to sort of renting. So in this sample, I'm only looking into households who own the property prices, right? So I'm not sort of looking into those that are renting. But I can find the answer to your question with the data. I just do not know that because I'm only focused on household owners as opposed to household renters. And so hopefully that addresses your first question. The second question on social cultural context of ownership of real property between North America and South Asia are radically different. I completely agree with you on that. So how does market values of real property in Nepal affected? So I'm mindful of the fact that these settings are drastically different. The cultural setting is very different. And so that's the reason why, if you look into the magnitude of the parameters, it's much more different. The sign is identical, but the magnitude is much more smaller. So, other than kind of acknowledging that these are different settings, I'm not really able to sort of say something confidently on what could be sort of playing a role here. But I'm with you there that these are two different settings. The only reason I am comparing these estimates to US studies is that I haven't come across a study done in a developing country setting trying to quantify the external cost of fires. And so sort of the comparison, we're just limited to studies done in the Western US.
Yeah, thank you. Prajwal Dungana is asking regarding the approach you followed regarding power radiative, how power radiative was measured.
Yeah, and so I see two questions. So Prajwal Dungana's question on measuring fire radiative power, it's actually part of the satellite data. So it's giving us the actual rate of radiant heat output produced by that specific fire located by the satellite, right? So I'm not really doing any computation. I'm just kind of borrowing that from FROM's data directly. And to Dr. Bora's comment on soil quality or soil erosion, indirectly, I do capture that through a set of fixed effects, but yes, it is an important channel that could be playing a role.
Yeah, another subjective question, whether the recommendations you made are applicable to many developing countries, particularly with reference to Nepal, whether the government is able to incorporate the findings that in crafting policies is that could make a relief to this fire affected areas. By Sambo Canal, he's asking this question.
Thank you, Sambuzi. I think that's a great question, and I hope I addressed that in my talk earlier too, in relation to how policymakers could be interpreting these parameters and sort of crafting effective policies, right? And so the two ways of thinking about is one is when we think about cost benefit analysis, right? So we want to make sure that the economic cost is smaller than potential economic benefits from different mechanisms intended to minimize fires, right? And so I give those two figures where essentially government is allocating $1 million annually, and I argue that it's not enough given the economic cost of fires I document in the study, which is in fact a more conservative figure, right? And so the other policy implication we want to think about is why is it the case that different provinces have some heterogeneity going on, right? Why is one province responding much worse than the other? And so what does that really mean for allocating funding across different provinces? And so it at least gives us some insights on which province or which area is ranked lower compared to the negative effect of fires. And so that might be one way to address policy solutions. But I'll be happy to talk about economic and policy implications in more detail, but I think I covered that in my talk earlier as well.
Naveen Adhikari is raising an issue that there is some conception or misconception that some people put fire in forest with anticipation that it will increase the yield. Is that also the case in some other countries or states that you have taken the case of Arizona, California, Colorado, Montana, in case of United States? So are these issues prevalent to other parts of the world, or this is just the local conception or misconception here?
I would argue that forest fires in the context of South Asia are more indigenous in that it's related to agricultural practices, right? There's the slash and burn practices that's associated with the agricultural season. So that's not really the case in the US where, US, I think, I would argue that the frequency of fires in general is less endogenous in the US compared to Nepal. However, to my defense, I'll also mention that since I think I saw one other point on agricultural season, I do break down the sample sort of by different months of a given year. So you can argue that if it's the channel that's playing a role, right, you should be able to see significant differences between the effect of fire on property values in agricultural season versus immediate after the agricultural season. I do not see significant differences when I do that. So that might be one indirect way of kind of arguing that although it's not perfectly exogenous, it doesn't really seem to be playing a role in the context of Nepal. However, I'm with you that it's not a clean stock like say an earthquake is or other natural disasters, right? So that's something I am mindful of, but I do conduct other robustness checks to argue that that's probably not playing a role here.
Yeah. The concern of Ashwasan, I think we have incorporated in the policy implications regarding the relationship between forest fire and community forest management.
Yeah, I think that's a good point. There have been some studies. In fact, there's a nice study that came out in Nature Sustainability a couple of years back by Arun Agrawal, Kate Sims, and a few other collaborators that showed that community managed forestry has in fact led to a decrease in deforestation in Nepal over a longer period of time. And so there's a lot of interest in looking into, does decentralizing forest regime lead to better environmental outcomes, right? And that was the reason why I was a little bit more focused on community forestry. And so I have a couple of ongoing work looking into, are there differences in environmental outcomes between community managed forest as well as government forest in terms of forest fire events, right? So that's something I'm not really able to tease out right now, but that's certainly, kind of argued a lot in the literature and should be mindful of.
Yeah, one concern by Professor Bora again is that he's considering about forest fire insurance, whether that could be feasible in our context.
That's a great suggestion. To the best of my knowledge, we do not have that in place as of now, but I recently came across a grant proposal that's in the context of Nepal that's trying to look into the efficacy of such an insurance program. And so I'm curious about the implementation. I cannot talk about fire insurance specifically, but in the past, I've looked into other policy interventions such as subsidizing agricultural inputs to poor farmers. And unfortunately, in the context of Nepal, there's always unintended adverse consequences associated with implementing an intervention. And so we'll have to wait and see how the program is implemented and sort of take into account different constraints. But that's one channel that has been in place in the Western US at least. And I'll be curious to see how that's done in Nepal.
Yeah. Yeah, one concern regarding this radiation variable, whether this is how much it is influenced by number of forest fire or the intensity of forest fire, some sort of methodological question.
I think I missed that. Sorry, could you repeat that?
Yeah, number of forest fire and radiation variable, the relationship, how that has been established in the paper.
Okay, so they are positively correlated, if that's what the question is all about. So the count is essentially computed, right? So active fire locations are detected by the MODIS satellite. And what I really do is I kind of collapse, right? How many unique fire events happened within a given district in that specific month of a given year. And I use that average number in the main empirical specification that I presented. Now, average may not be the perfect summary statistic to go with, and I do look into other sort of indicators to explore the robustness of findings, but that's essentially coming from data directly. And FRP is for every active fire located by satellite, it also spits out the intensity or the FRP associated with that unique fire location, right? And again, collapse that at the district year month level and use that in the empirical specification. So I'm not really computing anything new. I'm just kind of collapsing them at the right level so I can merge the fire data with the household level data, and I run a regression after that.
Yeah, Kapil has raised one issue that in terms of your review, the incidence of fire has decreased after corona pandemic, But in case of Nepal, the number of forest fire significantly increased during or immediately after Corona first phase of Corona pandemic. So what might be these reasons behind these differences?
Yeah, I think we all know how terrible the situation was in the context of fires over the last 2 months, right? In April and March, we had a lot of fire events in Nepal. The study that I was referring to, which I worked on last year, was more of a short-term study when lockdowns were much more stricter back in March and April of 2020. And I was able to exploit the variation in lockdowns across districts to show that the frequency of human-led fires was much smaller in magnitude for that small period of time, right? Then what's explaining what we saw in 2021 April and March? That's not something I can I can relate to based on what I have done in the past. We'll have to kind of, I think it's also associated with if you kind of look into the panel of MODIS data, right, it tends to be larger in magnitude during March and April of every year, right? And so I'm not really able to answer that, but I'll be happy to look into the long-term effect of the pandemic on fire events based on your suggestion too.
Yeah. One more concern by Ram Acharya is that this forest fire more often caused by the dwellers in the marginal lands in our context. So how are policy implications could be supportive to control this sort of events happen?
Yeah, that's a great question, right? So, we hear a lot of anecdotal evidence on those sort of specific socioeconomic groups. Unfortunately, right, when I'm thinking about policy here, I'm kind of thinking about it at the country or at the province level, and I'm not really able to sort of say something more meaningful about sort of inequities across different socioeconomic groups. So that's something, I would love to dig deeper, but I'm not really able to sort of confidently assert how should we be going about it.
Yeah. There is one suggestion by Dhruva. He is suggesting the presentation of the number of fires and fire intensity together in this in the table that you have presented would be more clear to the readers.
Yeah, so I think let's see if I can. Oops, let's see. I think I did have the summary statistics of those two things, right? So column 8 and column 9 is giving the summary statistic, or at least the average for each month of a given year. So you can see that, when the average count was 3 fire events, the FRP was or almost 18 megawatts, right? So again, this is the average. So I don't really want to, say too much, but the summary statistics is in the paper if someone is interested in looking into it.
Yeah. Kedar Neupane is asking, what is the primary reason behind the collapse of house prices due to forest fire? There's some sort of explanation is missing in the paper.
Sure. That's a fair point, right? I mentioned that there could be 3 potential mechanisms, right? One could be actual fire damage, which I'm not really able to test. There could be perception of risk, right? So as economic agents, are we responding by sort of understanding that this is a huge risk to our environment, right? So I am interpreting the change in parameter more as risk perception to an environmental shock. And then there could also be the visual disamenities aspect, right? That a lot of US-based studies document. So the data that I have, it doesn't allow me to tease out what mechanism is in fact driving it, right? I would say that it's a step forward in that at least I find some significant negative effect going on. And so future work may benefit from sort of teasing out what channel is actually driving these effects. So that's a great point, but it's beyond the scope of the paper right now to look into that.
Yes, Dr. Fuyal from National Planning Commission is asking that about some social protection and security issues within environmental disasters. If we can incorporate other climate change variables in the given model?
Yeah, we can certainly include quadratic specifications of temperature and precipitation in the model. And when I do that, I do not see that the estimates change drastically. right? So, that's one characteristic or factor I can think of adding the model. But I would be also adding the caveat that when I plug in temperature and precipitation, it's not available at the village level, right? I'll be looking into monthly average temperature and precipitation at the district level, right? So there could be some variation happening at a much smaller spatial unit. But yeah, those things could be incorporated in the model. The only reason I do not include them right now is I'm sort of relying my model based on what's been done in the prior literature, and I'm following that. But that's a good point.
Yeah. Thank you, Dr. Jayash. You have responded all the queries put in the chat box, including this methodological issues, the conclusion, implications, and others. So if there is any other question left that we can use a couple of minutes to address them, you can voluntarily raise your hands. If not, we'll go to concluding session. You can just unmute your mic and then ask questions if something is left.
We are also 2 minutes over time, so I guess maybe we should close the session if there are no questions.
Yeah, I don't think there is any additional questions, so we can go to concluding remarks. Dr. Acharya and Dr. Biswash Gauchan, you can put your concluding remarks and close the same webinar, I think. Thank you very much for all your participation.
Okay, thank you, Dr. Acharya, for moderating the Q&A session, and for Dr. Pordell for presenting. I guess now I'm going to invite Dr. Gauchan to close the event.
Thank you, Dr. Acharya. First of all, let me thank Dr. Jayash Paudel for presenting a very interesting paper on the implication of forest fires on property values in Nepal. Forest fires are quite common in Nepal, causing a huge environmental and economic damage to a very fragile ecosystem. The paper has established a causal relationship between these two variables, though the relationship is less significant considering the broader context of the property price dynamics in Nepal. The causal relationship in other countries where the forest fires are common are quite significant than what seems to be the case in Nepal. Broadly, the property price in Nepal are largely driven by factors such as irrational expectations, availability of cheap bank credit, higher general price level, and inflation. With very little bank credit flowing into the productive sectors of the economy, credit is largely mobilized for financing imports to meet ever-growing domestic consumption and financing real estate and financial assets, which in turn is fanning asset prices. I found today's presentation extremely important given its larger policy implication in view of the recurring occurrences of the forest fires across the country. The presentation might have sounded very technical to many audiences because of the complexity of the methodology and the nature and sources of data, as econometric models generally tend to be. I found the outcome of the research very insightful and useful. I'd like to congratulate Dr. Paudel for his excellent work. I take this opportunity to thank Dr. Sanjaya Acharya for moderating today's session, which was very interactive. IIDS owes it to Dr. Avidit Acharya for steering IIDS monthly webinar series in politics, economy, and public policy. We are encouraged by the level of participation and the quality of the papers presented in our monthly webinar series. Finally, I would like to express my gratitude to all of you for participating or accepting our invitation and participating in today's session. Your participation and interest will shape our future episodes. Before I conclude, I also take this opportunity to thank my colleague Vinisa Nepal for coordinating this webinar series. Thank you very much for your participation. Thank you.
Thank you.
Thank you very much, everyone.
Great presentation.